In this video, we will take a closer look at how the technologies that recyclers use to sort plastic waste work. Sorting technologies either rely on the differences in physical properties between polymers, such as their density or electrostatic properties, or they use optical instruments that are able to distinguish different polymers. Often a combination of methods is used to achieve the desired result. An example of a method that uses differences in material properties is sink float density separation. In this method, mixed polymer waste is introduced into a flotation bath filled with water or another liquid. Because of the different densities, lighter polymers such as polypropylene and polyethylene will float and can thus be collected from the surface. Heavier plastics like polystyrene or ABS will sink to the bottom. By using additives that change the density of the flotation liquid, different types of polymers can be sorted in this way. However, the effectiveness of this method is limited by the fact that different polymers have density ranges that can overlap one another, as shown in this graph. Sink float separation of polymers with overlapping density ranges would require additional technology that makes the flotation process more precise. A promising, but not yet widely used method is called selective flotation separation. It makes use of the difference in hydrophobicity between polymers. Before the polymers enter the flotation bath, the particles undergo a surface treatment that selectively changes their wettability. This means that when air bubbles are introduced from the bottom of the flotation bath, they will attach to the more hydrophobic polymer fragments, which will then begin to float upwards. The more hydrophilic particles will have a completely wetted surface and therefore won't start floating. The characteristics and limitations of these type of density-based sorting methods have clear implications for design for recycling. First of all, permanent connections between different materials should be avoided to prevent polluting one or the other material stream or making separation impossible. Also, try to avoid additives, coatings and polymer blends. These can change the density of the polymer to the point where it will be misidentified, again potentially polluting other polymer streams. Further, electrostatic properties can be used to separate polymers. This is known as triboelectric separation. First, the plastic particles are shaken in a charging unit in which they rub against each other, which causes different polymer particles to become charged. A conveyor belt then guides these particles towards an electrostatic field that deflects the differently charged particles into different containers. There are also technologies that use optical instrumentation to sort streams of mixed polymer particles. A commonly used method is near-infrared spectroscopy. It is a relatively fast method that doesn't require surface pre-treatment of the particles. It is based on differences in absorption of near-infrared light by different polymers. After the plastic particles are illuminated, a near-infrared sensor detects the reflected wavelengths. With this information, a processor unit determines the polymer type and sends a signal to an air jet, which blows the different polymers into separate containers. A limitation of near-infrared spectroscopy is that it doesn't work well with dark colors, especially black, since these absorb nearly all light, also in the near-infrared. It can also run into problems when labels or coatings cover the surface of a material, which will cause a false reading by the sensor. In addition to near-infrared, there are other optical methods that use X-ray or laser technology to distinguish between polymers. After sorting, certain flakes will remain undetermined, either because they are too contaminated or because they were not successfully identified. This residual stream will most likely be incinerated for energy recovery. In a circular economy, this is considered a leak in the system. However, in some cases, mixed plastics can be applied in products of relatively low quality. But this is to be avoided too, as it implies that the product is made with ill-defined composition, This makes its future processing after the next life cycle very hard. A related design consideration is to use common plastics only. Common polymers such as polyethylene, polypropylene, ABS, polycarbonate and polystyrene are already being recycled at scale. Therefore, they are much more likely to be recovered than uncommon plastics, which are retrieved in volumes that are too small for viable recycling. These less common polymers are likely to end up being incinerated as well. Knowing how different sorting technologies and the principles on which they are based work helps to understand why certain design choices can improve or decrease the recyclability of a product. Understanding the basics of sorting is essential to make the proper choices for recyclable materials when designing a product.